Hello, advanced math students, advanced honors math students. Today is Thursday, April 2nd. This is our fourth day together of the new 9 weeks. We are going to start a brand new chapter. If we had our books with us and had our books out, we would turn to chapter 9. And the topic or the name of the entire chapter is something called conic sections. What you see in front of you right now, I'm going to make some notes and give an overview on, in general, what conic sections are and what that means. I would think you had some background on this last year in Advanced Algebra 2. You do not have to write this stuff down as part of your official notes for today. This would be a reference sheet that I'm creating that I'll put under here and show you as needed on a daily basis. I just want to give a quick overview on the topic of conic sections, and then your notes for today, the topic will be called circles, and these are the 4 or 5 problems that we're going to do together here in a little bit. So for now, just pay attention, a real quick overview. When I say conic sections, those are the 4 pictures that make up this group. And the 4 pictures we're going to learn how to draw, hopefully accurately and correctly here, are as follows. We've got circles, we've got ellipses, we've got hyperbolas, and finally, the last category would be parabolas. Now, as I work my way through these and talk about them very briefly today, we will then focus on one different conic section per day for the next 4 days in a row. Circles, of course, shape-wise, are just perfectly round objects. You've worked with circles your whole life, a lot, of course, in geometry. Ellipses are more elongated egg-shaped type pictures. They could be elongated horizontally, or they could be elongated vertically, and you'll see the difference in the formulas for each. Hyperbolas are going to look like parabolas, like curves, but they'll end up facing in opposite directions. So it could be a hyperbola that opens left and right, almost like 2 satellite dishes facing opposite directions. It is also possible to draw a hyperbola facing up and down on a coordinate system. And again, I will get into details as to how you can tell the difference between each based on the formulas we'll work with. And finally, parabolas. You've drawn parabolas before. Usually a parabola has been either a smiley face or maybe a frowny face, and those were called, remember, quadratic functions. It is also possible, algebraically, to create formulas that produce a left or a right-facing parabola. Notice it's just one picture here. It's either a smiley, a frowny, a lefty, or a righty. But we've got parabolas, hyperbolas, ellipses, and circles. And those are the 4 conic sections we'll cover. Today, we're going to focus on circles. So a couple of notes on this paper, then we'll jump into the paper you're going to produce. The standard equation of any circle will always look like this. X squared plus y squared equals r squared, where r, of course, stands for the radius of the circle. So if I've got a circle centered on the origin, you will see a good old x squared plus a good old y squared equals, and then there will be some number on the right that's represented by the radius being squared. Okay? So for example, if I wrote x squared plus y squared equals 25, the standard equation I just created tells you it's a circle because it's an x squared plus a y squared scenario. Oh, and since there's a 25 over there, the radius must have been what? 5, because do you agree that 5 squared is 25? So circles will look like that. And if you ever need the center to be somewhere else besides 0, 0, The book would say the standard equation is x minus h squared plus y minus k squared equals r squared, and would look something like that. I'll delve into more details as we do some problems today. All right, general overview of conic sections right there. Your job today is to get a sheet of paper. It is Advanced Honors Math. Today is Thursday, April 2nd. Put the date 4/2/20, top left corner. The title of today's notes is Circles, and we're going to work our way through some examples. Now, I cannot go into as much detail and depth as a normal classroom scenario. Your goal at the end of this unit is to be able to successfully and confidently graph the 4 basic kinds of conic sections I just described without getting into a ton of details in terms of things like foci and eccentricity and lattice values and things like that. The details will be left for a later time. Right now, our goal is to just do the basics and know how to graph these functions, or excuse me, these conic sections. Okay, on your paper, I would divide your paper into 4 parts. We're going to graph 1 circle in each block. The first one is very, very simple and basic. You can see it says x squared plus y squared equals 9. Okay, I'm going to cover up that number for a minute. If you see x squared plus y squared, that's telling you that it's the standard equation of a circle. And because there's no numbers attached to the x squared and the y squared, for example, what I mean by that, if you look at number 2, the x has a -2 and the y has a +1. That tells you the center of your circle is getting moved to some different location other than the origin. So bottom line is, if you see plain old x squared and plain old y squared, you've got a circle whose center is the origin. So I'm going to draw me a circle. The center of the circle is right on the origin. And then all you got to do to draw a nice, neat circle is know how big its radius is. Now, notice that says 9. The radius is not 9. What number did you square to get 9? Obviously, that would have been 3 squared. So the radius is 3. If I made a note on that, I'm going to go right 3, left 3, up 3, and down 3. Oh, and now that I know the center is 0, 0, and the radius is 3, you can draw a nice, neat, beautiful circle whose radius is 3. Okay? So whatever the number is on the right, you will square root that number to produce the radius of that circle. Okay, let's go to second problem, block number 2. It's got an x squared and a y squared equals 16. So again, it's a circle. But notice there's numbers inside those parentheses, shifting your center to some other location. Okay, here's the key. The center of this circle is always found by taking the opposite sign of what you see in the parentheses, the opposite sign. So since that says x minus 2, my x coordinate's 2. And since that says y plus 1, my y coordinate is -1. So the center of this circle is 2, -1. The radius, of course, is the square root of 16, because what number did you square to get 16? My radius is 4. I have everything I need to draw that circle accurately. I am indeed going to go right 2 and down 1. I'll put a little C for the center. And because the radius is 4, from that center dot that I just created, I'm going to go left 4, right 4, up 4, and down 4. Now I can connect my dots and sketch my circle. Right now our goal is to accurately sketch the circle they've given us. Okay? 2 for 2. Everybody go to block 3. Notice something a little bit different is happening on each problem. If you now look at this problem in the third block, I noticed something different. If you were playing detective here, this x plus 1 squared has a 3 in front of it, and that y squared has a 3 in front of it. The standard equation, notice, is just good old x squared plus good old y squared. We don't want numbers in front of the x squared or in front of the y squared. So my instinct is telling me that those 3's do not belong there. For me to get this into standard form, I would divide both sides by 3. These 3's would cancel on the left side, correct? They're now gone, giving me x plus 1 squared plus y squared equals what? 4. And I successfully got my circle into what's called standard form. When I go to graph this, notice the center of this circle is going to be where? What's the opposite of plus 1? Negative 1. And since it's good old y squared and there's not a number attached to the y, my y coordinate is 0. The radius, of course, would be the square root of 4, which is 2. So now that I know the center and I know the radius, I should have no problem sketching that circle. I'm going to go left 1 and up 0 for my center. I'll put C or CR for the center. The radius is only 2, so obviously I'm going to go up 2, down 2, right 2, left 2, and my circle has been successfully drawn. Okay? Finally, we go to block 4 over here. Once again, I see an x squared and a y squared. So I'm thinking this is some kind of a circle. But once again, there's a coefficient that matches that's in front of each of those parentheses. When that coefficient is the same, in this case a -4 and a -4, that tells you this is a circle. If they're different, by the way, sneak peek for tomorrow, that'll tell you it's an ellipse instead of a circle. But notice here, I'm going to divide both sides by -4, creating what? X minus 1 squared plus, because the -4's all cancel out, plus y plus 3 squared equals a negative over a negative is a positive 8. So now careful, when I go to sketch this circle, the center is going to be what? Opposite of -1 is 1. The opposite of +3 is -3. So I'm going to go right 1 and down 3. There's my center. Now careful, when I ask you what's the radius, it's not 8. It's not 4. Don't just cut that number in half. Remember, you square root that number. And the square root of 8 is probably what? 2.8 if I had to round it to the nearest tenth. So I'm going to go up 2.8, down 2.8, right 2.8, and left 2.8. And my circle has a radius of 2.8 with a center at 1, -3. And I've successfully sketched all 4 of those circles. Finally, the last teaching point. So flip your notes to the back. Go to the back of your paper. Now, on the back of your paper, unfortunately, the marker I was using showed through here. Let's focus on the question. Go ahead and write down this question. It says, the point 3, 4 lies on a circle whose center is at -1, 2. Write an equation in standard form. So we don't even need to graph this one. This would be an ACT type question, college entrance level question, a question you might have to do in calculus before you find the slope or the area of that circle. So the point 3, 4 lies on the circle, and the center is at -1, 2. And you're supposed to write an equation for that circle in standard form. So let's give it a shot. I'm going to grab another sheet of paper here real quick. Okay, let's just simply sketch what we're seeing here. It said the point 3, 4 lies on the edge. So here I go. If I draw my circle, if I go right 3 and up 4, right 3 and up 4, right 3, up 4 lies on the edge of my circle, And it did tell me the center was -1, 2, which is right here, left 1 and up 2. Oh, so there's my center at -1, 2. Freeze right there. If my goal is to write this equation in standard form, I already know that in parentheses I'm going to have x. Now remember, it was always the opposite of the sign that you saw in there. So since our center is -1, 2, I would write x plus 1 squared plus, and then what? Y minus 2 squared equals, and the obvious point here is, don't I have to figure out the radius of that circle by seeing how far it is from that dot to that dot on the edge? Okay, so really, don't you have two choices? Couldn't you use the distance formula from this dot to this dot? Or, since I'm simply connecting two dots, couldn't I, in my mind, go up to and write, what would that be, 4? If I have an accurate sketch here, and that would tell me, since this dot was on 3, 4, and this dot was on -1, 2, up to, and actually write how many? 4. This would be 2, that would be 4. I could simply do the Pythagorean theorem and go a squared plus b squared equals c squared. So 4 plus 16 would be c squared. 20 would be c squared. So think about it. The hypotenuse of that right triangle, which is really the radius of the circle that I'm picturing, right? If I square root both sides, the hypotenuse, which is my radius, would be radical 20. Well, back to my standard equation here, since it's always radius squared, if I took radical 20 and squared it, I would get 20. Oh, and so I've answered the question by taking that circle whose center and point on the edge I knew. I created an equation of the circle in standard form. So that's just one little thing they could ask you to do to confirm in your mind that you know how to work backwards and create the equation if they gave you some details rather than giving you the equation and sketching the picture. And then finally, the last problem in your notes, again, I want to make sure you can read it correctly here, says, ooh, there's a star by it. It must be important, right? Or a tough one, or a challenge type problem. 3x squared plus 3y squared minus 12x plus 18y minus 20 equals 0. We are supposed to graph that circle, but how in the heck can we graph it if we don't know how to get it into standard form? So let's attempt this problem right here. If I'm going to try 3x squared plus 3y squared minus 12x plus 18y minus 20 equals 0, isn't my job to get it into standard form like the 4 that we did on the front of our paper? So what I'm thinking, step 1 should be, wouldn't it be to kind of group your families together? Think about it. I've got a 3x squared minus 12x. Don't they belong to the same family because they both have x's? I'm going to leave a blank space there and then go on to the next family, which says 3y squared plus 18y. Leave a blank space as well. And on the other side of the equal sign, since that minus 20 doesn't have an x or a y attached to it, do we agree that that minus 20 currently doesn't belong to either the x family or the y family? So the minus 20 is going to get added over to the other side and will end up on the right side of the equal sign. So step 1, kind of reorganize your equation and get the x family together, the y family together, and put the constant to the right side. Now, it's, I hope, obvious to you that if I've got 3x squared minus 12x and a blank space, aren't we going to use that technique we've been taught in our past called completing the square? But if you remember on that technique, you're not allowed to complete the square when there's a number or a coefficient in front of your x squared. So in this first group, I'm going to factor out a 3, It's going to give me x squared minus 4x and a blank space. Plus, look at this second family. I'm also not allowed to have a coefficient in front of the y squared, so I'm going to factor out a 3 there, leaving me with y squared plus 6y and a blank space equals 20. Okay, that was step 2. Now, step 3. I'm going to ignore this 3 for a second. Oh, remember completing this square? How did you fill in this blank space at the end? Okay, you ready? You cut the middle number in half and then square that answer. So if I take -4 and cut it in half, that'd be what? -2. If I take -2 and square it, -2 times another -2 is +4. And remember, whatever you do to one side, you got to do to the other side. But hold on a second, that +4 that I wrote has got a dot connected 3 in front of it. So knowing this 3 gets distributed to everything in there, that really was me adding 12 pounds to the left side of the equal sign. So I got to add 12 pounds to the right side to keep my scale balanced. Okay? Same thing's going to happen here. Watch. I'm going to ignore this 3. I'm going to focus inside my parenthesis. If you cut 6 in half, what do you get? 3. 3 squared is 9. I'm going to write +9. So you're tempted to go write +9 on that side, but remember that 9 has a 3 in front of it, right? So technically I'm adding 27 to the other side. So now as I fix all this up, I've got 3 parentheses, and if you remember on completing the square, your job was to take everything in here, which is a trinomial, and to factor it into 2 binomials that would both be exactly the same. So it really would end up being a binomial squared. And all you do in here is remember whatever you got when you cut the middle number in half is what you put inside here. So when we took -4 and cut it in half, what did we get? We got -2. Plus, do the same thing here. This perfect square trinomial is going to end up being a binomial squared. What did we get when we cut +6 in half? It was +3. So this is y plus 3 squared equals 20 plus 12 plus 27. Oh gosh, what is that? That's 32 plus 27. That would be what? 59? And finally, for me to get this circle into standard form, I'm going to divide everything by 3, because remember on the front, we don't want that coefficient 3 to be there. And I end up with x minus 2 squared plus y plus 3 squared equals, and then whatever 59 divided by 3 is, I'll divide that on my calculator real quick, and I get 19.7. And I was able to get my circle into standard form. Now, if I told you to graph that, the center would be where? 2, -3. And the radius would be whatever the square root of 19.7 is. And we could successfully draw our picture based on the center and the radius. So the 2 problems on the back of your notes were 2 extra kind of problems where, given some information, you had to successfully get your circle into standard form so that it could then be graphed if needed to do so. Okay? So I hope that makes sense. That's an introduction to graphing circles. Your homework is as follows. This will be due tomorrow by noon. So since today is Thursday, April 2nd, this is due by Friday, April 3rd at noon. You've got these 5 homework problems, so hit pause and copy these down real quick. You're to graph the first 4, and then on number 5, you're supposed to organize and work your way through it like I did that last problem and simply try to get it into standard form. So we're going to have a graph, a graph, a graph, and a graph. Successfully draw all 4 circles correctly after getting them into standard form. And on problem 5, do the completing the square technique. Try to get it into what's called standard form and see if you can accomplish that goal. Remember, any questions, you can always go back, watch this video again, and repeat the steps of any problem that's causing you difficulty. That is not an option. Use the video, use my explanation as a tool to look back, redo a problem, listen to a problem again if need be, so you can attack these and do them correctly, okay? X squared plus y squared equals 25. X plus 3 squared plus y minus 2 squared equals 12. 2 parentheses x plus 1 squared plus 2 parentheses y minus 4 squared equals 18. 5x squared plus 5 parentheses y minus 2 squared equals 30. And finally, x squared plus 2y squared plus 8x minus 16y minus 10 equals 0. Okay, good luck. That is due in email form to me by Friday, April 3rd at noon. Okay, guys? See you tomorrow. Bye.